So, hi everybody, and welcome to this video number 11 in the solutions series. So, in this video, in the previous video, what did we do? We discussed about solutions of gases in liquid solution and liquid in liquid solutions. There we discussed about Raoult's law, Henry's law, applications of Henry's law, and various other aspects. Here next, we'll graduate to a third type of solutions, that is solid in liquid solution. So in particular, very important, we will only be discussing about focus only on non-volatile solute. So that is your solid. It should be non-volatile. Okay. So at a given temperature, at given temperature and at equilibrium conditions, the pressure exerted by the vapors of the liquid over the liquid phase is called vapor pressure, right? Now you have your solution, you have your liquid. So these liquids will have vapors. Okay. And whatever the pressure is being exerted by the vapors over this liquid is a vapor pressure, right? So now let us compare the vapor pressure of vapor pressure of solutions versus pure liquid. See, in solutions, what solution are we talking about? That is solid in liquid versus pure liquid. इसमें भी सॉलिड में मतलब नॉन वोलेटाइल सॉलिड, सॉलिड इन लिक्विड versus pure liquid, right? So this is what we're talking about. Now in a pure liquid, what happens is here I have to draw the entire surface is occupied by the molecules of the liquid in a pure liquid, right? Molecules of solvent, okay, which happens to be a pure liquid. But the same thing if I have to draw for a solution, what happened is, sorry for that. So some of the solute has been added, non-volatile solute is added. Right? Now what happens is the number of solvent molecules. So as a consequently, the number of solvent molecules escaping from a surface is correspondingly reduced. Thus the vapor pressure is also reduced. So see, the number of molecules escaping itself is reduced, right? Because there are some non-volatile, see, non-volatile solute particles which are blocking the escape of volatile solvent. Okay, so obviously, if there were about 10 molecules that would have escaped here, there are only about 5, 6 molecules. So obviously, these because the number has been decreased, the pressure that they are going to exert on this solvent molecules or on the surface of the solvent or liquid is decreased. So that is one of the reasons. So let us get into another reason. Okay, the second reason is the effect of the effect of the solute on the entropy of the solution. See, in a pure liquid, okay, the molecules have a certain disorder and a corresponding entropy. Fine. So vapor pressure of the liquid represents the tendency of the system to reach a higher entropy. Okay, you have a okay. So there are solute molecules, solvent molecules. Okay, so these have certain disorder and certain entropies there. But solvent molecules in its vapor phase represents higher entropy, right? So why do vaporization occurs? Because see, what is the whole game is entropy should be greater than zero, right? Entropy has to increase. The universe tends towards maximum entropy. So this will represent a higher the need for higher entropy. But what happens is, but when a solvent is added, The solution itself has a greater disorder than the pure solvent. Why? Because if this is your solution, these are your solvent molecules, and you have added the non-volatile solute, which is your solid. So you have added this. Now, what happens is if you want to pick a molecule at random, sometimes you might pick this. Let me change the color. Sometimes you might end up picking this, or sometimes you might end up picking a solute molecule. So which means here only randomness has occurred, right? So this represents disorder or randomness. Okay, so let me write this because a molecule chosen at random might or might not be a solvent molecule. Now, which means represents disorder, which means increased entropy, right? So, which means solution of the entropy of the solution is higher than that of pure solvent. Therefore, the solution has a lower tendency to acquire even higher entropy by the solvent vaporizing. In other words, the vapor pressure of the solvent in the solution is lower than that of a pure solvent or liquid. Okay, so just read once, you will come to know what is happening here. So, it has been experimentally found out that the decrease in the vapor pressure of the solvents depends on the quantity of non-volatile solute present in a solution. Irrespective of the nature of the solute does not come into play. Okay, so we have named for those properties that depend only on the number of particles relating to the total number of particles irrespective of their nature. So are called as, so these are called as what? Colligative properties. So colligative, the word comes from Latin. Co means together, bigger A means to bind. Okay. So these properties, which are these properties? Relative lowering of vapor pressure of the solvent, elevation of boiling point, depression in freezing point, osmotic pressure. So these are some of the colligative properties that we are going to study. So let us first go to the relative lowering. So vapor pressure of a solvent in solution is less than that of pure solvent. So it was Raoult established that the lowering of vapor pressure depends only on the concentration of the solute particles. And is independent of their identity. So P1 star, where P1 star P is the vapor pressure of the solvent in solution, P1 solution. P1 star is vapor pressure, the pure solvent. Now if delta P1 represents the reduction in vapor pressure of the solvent, reduction in the vapor pressure of solvent, so which is your delta P1 is equal to P1 star minus P1. So this is your P1 star minus x1 P1 star. So which is you take P1 star common, 1 minus x1 and your 1 minus x1 is x2. So this is the relative lowering of vapor pressure. Star P1 P1 star, which is your P1 star x2 divided by P1 star divided x2. So your relative lowering of vapor pressure of solvent is equal to the mole fraction of the solute. See, note that this relative, it depends, it just, what is mole fraction? Mole fraction is just a number, right, between 0 to 1. Yes or no? So it does not depend on the nature of the solute per se, it just depends on a number of solute particles. That is why relative lowering of vapor pressure is a colligative property. So in the next video, we will see elevation in boiling point. See you.